Yo, yo, yo. What's up? What's up? Welcome back. Today we're working on my stream start screen. So we're using this as an excuse to explore 3D rendering with OpenGL. And we've gotten to the point now where we have the scene. We're loading in some objects that we've exported from Blender. They have some sort of light applied to them, right? So we can kind of see that like as this thing's rotating, we're seeing like the light rotate with us. And so like we're seeing some like kind of like darkness on one side, brightness on the other. And we're getting pretty close to what like the final vision is. The final vision is like something similar to what we're seeing there. But oh shit, no recent files. Hold on. Give it a sec. Something similar to what we're seeing there, where we have like a monitor on a desk. But instead of the text kind of being overlaid like this, it'd be kind of cool if it's like showing on the CRT in some way. So that's what we're looking for. And something I wanted to work on was like making it look, it looks kind of like weird still. And I think that it would probably look a lot less weird if there were shadows cast by the light, right? Because it's like very flat on the table, despite the fact that the monitor should be blocking the light. So I wanted to work on that. And then I also wanted to work on, we observed yesterday, if things get too close to the camera, they just start to look like super broken. So let me just move the camera a little closer to everything. Maybe like 0.75. I think that's around the distance where we start to see it get messed up. And you can see like, basically like the top face of the table is like just fully disappearing. And I think I understand why this is happening. I spent a lot of time looking at this last night, and I think we can fix it. So I think what we want to do is we're going to start by fixing broken rendering with things close to camera, and then render shadows. Okay. So I guess let's just kind of start with the shadow stuff. Or not the shadow stuff, sorry, the broken render. So background on what we're doing here when we render. We take our mesh, and our mesh in this context is like a table, and he's basically got like a bunch of vertexes, where i.e. like points in 3D space that make up kind of his shape. Let's see if we can like open him in Blender, and that might give us something to visualize. So maybe I import an OBJ, and I go to work, stream, start screen, and I look at the table. So this guy's like got a bunch of triangles on him essentially, and we have like all of these vertices loaded into our program, and then we have kind of like sets of vertices that make up faces, right? So this is one face, these three vertices make up another face. Great. And these are kind of positioned in the world at specific locations. So like this is in world position like 3.3, negative 0.1, 0.6. And what we do is we apply like a transformation to each of these vertices after we upload them to the GPU. So we take all of these like vertexes and they're like vertexes, I don't know, whatever, in their like current position. We stick them on the GPU, and then we run this program on them that we call like 3T vertex shader that essentially like takes the vertex position and does like a transformation on it based off of where the model is in the world. We've got that set to like no movement. The model's just where it is at 0, 0, 0. And then our camera is positioned in some location, and we have to like take all of those vertexes and like put them relative to where the camera is, right? So if the camera's like over here looking this way, essentially that means that every vertex needs to be moved so that we're looking at it from here. And in OpenGL, there's no such thing as like perspective from like OpenGL's point of view. From his perspective, I guess, there's no such thing as perspective. Can I please have a brush? Why can't I draw on this? I don't know why this window is not working. What the fuck? It's like there's some button that's stuck pressed down. Oh my god. That's annoying. I upgraded yesterday, and so I guess this program that I used to use to draw on here. Oh, there we go. That seemed to fix it. Okay. Okay, so And from OpenGL's perspective, we have like a cube of that is like our world, and the camera is kind of positioned like towards us, like if in my drawing, like looking inwards. But with a key thing to notice here is that like in the real world, you have like your eyeball, right? And this is like a top-down view, and your eyeball has like some like field of view. And so like things that are the same size that are far away, right? This guy over here, he appears much smaller than like this guy who's here. Even though they're the same size, this guy's like taking up most of your field of view, and this guy's taking up like a small portion of it. And so what we do to like accommodate that is we essentially like stretch the world out like this so that these lines that are going to our eyeball become parallel. And so like we kind of render these guys in the world as like this guy's really small over here. And this guy, like, even though he was the same size here, he gets like stretched out so that he's like really big like this. And that's like how we do perspective. OpenGL doesn't care about perspective. He just cares about like this, like they call it orthographic view, where like everything as you go deeper in Z doesn't change. It's just all the Z is used for is for like what goes on top, right? Because like if I'm kind of drawing a line around this guy back here, he shouldn't even be visible because he's completely occluded by this guy in the front. And so we like need to use depth because when we draw both of them, we need to know which one wins essentially. And so what we are seeing in our little like demo here, am I not running it? Is that like in some cases, it seems like that's not working correctly. And I kind of like played around with this a bunch yesterday, and I found that our naive mapping here, the way we're doing this like projection is most people would use the like built-in, or not built-in, but they would use like this like thing called like a projection matrix. And we were like, fuck that, we'll do it ourselves, we don't care. And we kind of figured that if we draw this like top-down view again, where we have like some field of view, right? We have like some field of view, and we're calling this like 90 degrees right now. So we should actually draw this like it's 90 degrees, so it's like less confusing. This is 90 degrees. If something is like in this position here, we can draw like a triangle to that position like this. And basically all we need to find out to put this in that like cube for Blender, or not for Blender, sorry, for OpenGL, is like what percentage of the screen is this guy over from the left, right? Because in the OpenGL world, this is like -1 over here, and this is 1 over here. And all we have to do is figure out like, well, this guy, if he's like 100 to the left and like 600 deep, what does that translate to here? And so we haven't been changing this like 600. We've been just kind of like leaving that as is. And we've just been scaling this 100 based off this angle, essentially. So we can say that like he is tan this angle, tan theta is equal to 100 over 600. And so all we do is we just divide this guy by Z, and he'll tell us like, or like, sorry, the distance away from us he is. And that will tell us like how much of the, like what percentage of the screen over he is essentially, which works well enough. But it turns out that we have to adjust this depth number as well. If you look at like what people do for like GLM, perspective matrix, GL projection matrix, OpenGL is maybe what they call it. They end up with this formula. So how do I explain this quickly? They essentially end up with doing what we did for this, but they end up doing this like weird thing to Z, where F and N here are like far plane and near plane, because usually you also construct like a close and far clipping area so that you don't lose precision. You only have like the precision that you care about, essentially. And they do this weird thing where like the mapping isn't linear, like I would expect. Like I would expect that you can just like divide this distance in some way. But it turns out that's not true. So what they're doing is, if we like multiply this matrix out, this essentially comes out to, let's see. I'll see if I can like implement that real quick. Let's open up my vertex shader. Oops. This comes out to this term times the z position and this term times 1. And they've got like their negatives flipped, I think. So I think that this is if we have float far is equal to, let's say we're going to render like to like 3 meters away, and float near, we're going to say we're going to like render something 0.1 meters away. And this turns out to be f plus n equals f plus n over f minus n. All of this times the old z position, plus 2 times f far, or f times n over f minus n. That's what this term comes out to. And we'll like figure out what the fuck that's doing in a second, but let's just like apply this change first instead of doing what we were doing, and see if that fixes anything. And what if I type that in right, which it looks like I didn't, when I get this right, when I tried it yesterday, it did fix the problem. And so that was like the first big clue. Maybe I need to do still outfert, let's see, minus equals 1 or something to get it at the back face of the cube. No. Let me double check this. So they have far 3 near 0.1. Far plus near over far minus near times z. Maybe this is supposed to be a minus here. And that's still not right. Shit. Oh, oops. I don't want that there either. We're getting closer. Maybe both of these need to be negated. This needs to be negated as well. I might have got the negatives a little off. Because they might have the... they might be looking the other way compared to us. They might have their convention like backwards in terms of like which way is forward. I was pretty sure that when I did this yesterday, the math kind of worked out. So let's just double check that I'm not doing anything else stupid. First, let's turn off perspective scaling completely. That's probably the easiest first test. Okay, so that's the first thing we want to do. And then we can start scaling our z the way they're doing it and see if that kind of looks right. And it does not. So let's double check this math. So this is negative far plus near. Okay, we'll type it all out. Negative far plus near over far minus near times z minus 2 times f times n over f minus n. Okay, and then let's maybe adjust these near and far planes to try to get a little closer. So maybe we'll say 0.01 to like 5 just to double check. Oh, and I should delete this. And so now my question is like, why is this not working? Because this worked yesterday. And it looks like maybe we're clipping too close. So if I extend the far plane, do I see something like reasonable happen? No, I don't. So maybe I have to invert this. Because maybe their convention is backwards. Okay, there we go. There we go. That's looking more reasonable. We're closer. The far plane still feels too close. So can I not set this to like 100? Like, why is changing the far plane not affecting whether or not I see the object? Is it if I adjust the near plane? Something's not right here. Something's not right. Let's make a new term d is equal to r far minus near just to avoid like potential bracket errors. Yeah, I'm not sure what the fuck I'm missing here. Okay, well, I'm probably inputting this wrong, but let's just kind of like look past that a little bit and try to look at like what the fuck they're doing here. Oh, I'm sorry, because all of these, I see. All of this gets divided by z at the end of this. That's what I was missing. because they multiply their like divisor term by z. If you don't understand these matrices, don't worry about it. I'll just trust me here. So we have to divide both these by z. So it's actually divided by outvert.z here. And that should be more reasonable if I got that right. Is it this? Come on, man. I had it yesterday. I fucking had it. So let's one more time punch this in. So we have negative far plus near divided by distance times outvert.z divided by outvert.z. Okay, so that's nothing. This is minus 2 times f times near over d divided by outvert.z. And we're just going to try this one more time. And if that doesn't work out, we're just going to have to say, okay, I'm missing something, but we'll just say, trust me for now, that like when I punched this in correctly yesterday, it was working okay. Oh, maybe I have to apply this like XY scaling as well. Nope. All right. We're leaving it for now. But let's just say that they're doing something that's like a lot different than what we're doing, and it's scaling in an unexpected way, right? Like this isn't like a linear mapping of depth. And I was like doing a bunch of Googling, and it turns out that I thought the only constraint that we were trying to enforce is that z values are sorted correctly, which is like kind of true, except there's another constraint that is when I draw a face in OpenGL, right? Like I have like a wall here, right? He's got 4 vertices like this in 3D space. But if this is like going deeper into Z, like kind of like that way, I guess we'll kind of draw it more like it's going deeper into Z like this. And we have like a point here and a point here. What OpenGL is actually going to do is he's going to interpolate for each pixel that we draw. He's going to interpolate all along this. And so that actually means that we need a Z value that is like in screen space linearly interpolated. So here, when we're doing our like X mapping, we basically say that like we call like the new coordinates like U and V, where like we call like the world ones X and Y. And we essentially said that like U is equal to X over Z and V is equal to Y over Z. And if we do that, we get like this, basically this warped grid is shoved into this yellow grid. And a straight line in this yellow grid is like a curved line on this perspective grid. And essentially what that means is that like if we were to draw a straight line on this perspective grid, it would come out as a curved line on our like warped grid. And so that's like the clue that means that like we need to account for that in some way. And I think this graph shows it really well, where if you draw 2 straight lines in your like warped perspective grid, what ends up happening is they get mapped very strangely so that you see way more of the line that you're supposed to see after if you were to just like linearly map it this way. And so what they show is that like you need some form of function to offset that. And I was like doing a little bit of math, and I kind of found, let's see if we can figure it out here again. So we're saying that we have a mapping of like our like I space, we think we call it, like this view coordinate system, which is like X, Y, Z is vertical here. We'll say this is only X and Z. We won't care about Y for now. We'll only look at 2D. We're doing some mapping that is like x to z needs to go to like a new coordinate system, u, and before I thought that we could just keep the same z, but we actually need a new coordinate w. And we have like this constraint that a straight line in the first coordinate system still needs to be a straight line in the second coordinate system, so that we can like linearly interpolate in pixel space and get like reasonable depth values. And so you can write that as like z is equal to mx plus c, right? Like a straight line. That's like the line formula. And you can say that we also have like this new constraint that's like w is equal to n. Like we're just gonna rename the constants here because we don't really care about like how they're scaled. We just care about like the shape, essentially. So we can just say that like w is equal to nu plus d. And then we also have this like third thing that we've said is we already know that our u is equal to x over z. And if you just like maybe it's better if I do this in text because my handwriting is not legible. So we can say like z is equal to mx plus c, w is equal to nu plus d. Let's make this a little bigger. And then we have u is equal to x over z, right? We can do a little bit of shuffling and basically say, well, if we expect w, the new depth value, to be dependent on only the existing depth in our original guy, we can kind of like do some rearranging to try to get z's on the same side of each other. So we can like substitute x over z in this, so we can get like w is equal to nx over z plus d. And then we can rearrange this so that we get x on one side. So you like do w minus d is equal to nx over z. Then you do z w minus d is equal to nx. And z w minus d over n is equal to x. And then you do the same thing to this guy, where you get x on one side. So you can say like z minus c over m is equal to x. And then you can like equate these two guys. You can say z w minus d over n is equal to z minus c over m. And we're going to ignore a bunch of the constants here eventually, so don't worry about it too much. And we can basically like try to expand this out so that we get w in terms of z. So we shuffle things around so that we get w minus d is equal to n z minus c over mz. W is equal to nz minus c over mz plus d. And then we can like expand this out a little bit. So you get like w is equal to nz over mz minus nc over mz plus d. Z's cancel out here. And so we've essentially got like a new line formula. If you consider that like all of these like slopes and stuff are constants. N is a constant, m is a constant, c is a constant, d is a constant. That kind of like relate to like slope and position of the line. We don't really care about that. We only care about shape. So we get eventually, if you like kind of squash those all out, you can say nm plus d is like a constant. So you can say, we'll call that a new constant e. And this guy is basically a slope times z. So we're back to the line formula, where we have like, where we use m and o. We'll use a new constant o over z plus e. And so what's like interesting here is that our w term is like related to 1 over z in some way instead of z. And if we look up the formula for like Wolfram alpha, let's see. If we look up the formula here, we can say like f of x, we can just say like 1 over x, and that should just draw it for us. We get like this like curved line that looks suspiciously like the curved line we were seeing in this like projection from one coordinate space to the other. I'm not really sure if this is like mathematically like 100% correct, but other people have been saying that like, what's the thing I was Googling? 1 over z is linear in screen space. Which is like a thing that people, maybe I want to Google this instead of duck it because I want something better. So, this is the same thing we're just looking at. But somebody else had like a pretty good visualization as well. Maybe this one. Yeah, he's doing the same thing here essentially, where he's saying that like if you color these by relative to their difference in z values when using 1 over z, you get like constant colored walls. All this to say that I I kind of made this part up, this math up, but other people have like confirmed and come up with it first that 1 over z is like a linear way to represent the z values when you are interpolating in screen space, i.e. like by pixel by pixel. All of that to say, if I just apply our perspective the way we were before, and then adjust z by basically saying 1 over outvert.z, those artifacts that we see essentially should go away. And they have to some extent, except we've got to like adjust our clipping. So we just have to like adjust this guy by like making sure that his range is big enough and that he starts at like a reasonable spot. So by like adjusting his near and far plane. So we'll adjust the near plane, I guess, to be like minus 50 or something. I just want to like get, maybe we'll start something lower, minus 1. Is that getting closer or farther? I'm actually not sure. Minus 2. Minus 2 is 2 gone, plus 2. This is the mathematical way to do this, for sure. Plus 1. I'm losing it. Losing it. Give me a sec. So we'll add like 0.2. I just want to like see, I'm trying to like figure out where the near plane is ending up. If I do plus 0.5, he looks the same, plus 0.7. Something is still wrong here. Maybe I need to I might have to negate this whole thing actually. Because I might be in the wrong corners. There we go. Perfect, that's what I was missing. And so here we see that we do, in fact, have a table that looks like a lot more reasonable, which is pretty sick. I can't say that I like confidently understand why that's the case, but it does sure seem like that's a lot fucking better. And so I've like rationalized it enough in my head that I feel like I'm okay with that. But yeah, pretty interesting problem. And I think this is kind of why it's fun to like implement this kind of stuff yourself, because I don't think I ever would have gained like a reasonable intuition about this if I hadn't fucked it up in the first place. So pretty happy there. I think that we can probably do a little bit more math to say that we could set our like near and far clip planes to say that like we know that 1 over like near plus b is equal to -1, because like our thing should be -1 to 1, and we know that like 1 equals 1 over far plus b, and so probably there's like a way to solve for the two of these. Probably. If you tried to solve, I guess this is like m here. You have like some slope and some cutoff. And you can solve for these two variables. But this seems to be good enough for now, where I just like hard punch in some numbers here. Probably don't even need to set a near plane. Yeah, that seems fine. I bet if we reduced this value, we'd get like a reasonable far clip. Maybe we need to reduce it even more. Like divide by 5. Maybe divide by not 1, maybe no division at all. Oh, here. So that's defining our start clip plane. But you can see that like now we're clipping and we're not getting like artifacts. We're just clipping. So I think all in all, that's kind of working. So pretty cool. So we'll probably have to come back to this at some point to fix like near and far clip, set the clipping planes intelligently. But for now, I think we'll call it there, which is pretty cool. Okay. So I guess before we call that a day, let's just git status, git diff, and say git add -u and say we fixed artifacts on things close to camera. And we will write a better commit message for that later. But for now, that's good enough, just so that I have it like chunked in my head. And the next thing to do is render shadows. So shadows, pretty fucking crazy, it turns out. So what we need to do is when we look at this scene, let's maybe look at it in Blender. This isn't the scene I want to look at. I want to look at this scene. Close this window and maybe save it again so that every time I open this, it doesn't open that. But say we have like one light. Let's make one directional light like we have in our OpenGL world. I think the sun acts like a directional light, and I think that if I delete this guy, here we go, nice, 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 and I can like cast a shadow. Essentially, what we need to do is we need to know what is blocking that light from hitting this table, right? And it turns out, I was like Googling this because I was like, I couldn't really think of like an easy way to do this. And it turns out what the normal trick here is you just render the scene twice. Once from the perspective of the light, and you like just look from the perspective of the light and you say like, well, what can I see? Oh, I can't see the table back there. And then when you render it from the perspective of the camera, you like look up essentially what you rendered the first time around, and you see like, well, can I see it there? Which is pretty funny. Pretty funny workaround, and it kind of like explains why in like Godot, when you're like setting up lights, they don't cast shadows by default, and you have to like click cast shadow, and it's like, oh, that's because it's like fucking expensive because you have to render the whole world again for every single light. But I did want to try implementing that and see what happens. So I guess in our situation, the situation of the sun, we don't have like a specific point for a light, right? It's kind of like it's implemented as like kind of like a constant stream of parallel light lines coming in the same direction. So if I have like an object here, it doesn't matter like where it is relative. Oh my god, please select. There we go. It doesn't matter like where it is relative to all these. It's always going to get light coming in at the same angle. It's kind of like the model that we're working with. So we need to make sure that we're kind of rendering our light that way. And so what we could do is we could do like an orthographic render, i.e. like no perspective. Can I turn that off here? I thought there was a way to visualize as orthographic here. But anyways, you can do like a no perspective render from the position of the light at the angle that the light is traveling. And I think that as long as we zoom out enough so that we can see everything in the scene we care about, we should get enough of a shadow map to get what we want. And you could probably do something clever, like you could calculate what's visible from the perspective of your camera, and then make sure that like you're only moving back far enough to see everything in there. But I guess you may also need, like, if you had like a skyscraper, or like if you had like a block here, even though that's not in view of the camera, that's still casting a shadow. So maybe you just have to zoom out far enough that you see like everything in the whole fucking world. Anyways, we'll experiment, we'll see. Did you end up going deeper into SDF with like the font rendering stuff? Not too far. I did end up applying some like filtering to it. I saw here, let's see. I didn't do it like on stream, but probably if I look up my YouTube video on it, I posted a comment somewhere where I looked a little closer. Probably this one. Pause. Shut up. Yeah, so I did like a little bit of like feathering of edges with some of the techniques that I saw in like this video here. Glyphs, shapes, fonts, and sign distance fields. And basically all I did was like increase resolution and like fuzz the edges a little bit. So nothing much, but a little more than you probably saw that on that stream. So if you like look at the what we have right now, I think that the font looks like a little better than it used to. If you like zoom in on this, can I zoom in on this without like fucking everything up? I don't know if that zoom applies on stream. I don't know, but it looks a lot better than it used to. Anyways. Okay, so let's try implementing shadows. So I guess the first thing to do is figure out, I guess, we'll just start with a render from the perspective of the light. And we'll kind of like break it down from there. Yeah, we'll just break it down from there. And I guess we'll say that we kind of just shot the shit for a few minutes there. So we'll say we're starting this at 3530. Hey, what shadowing technique are you thinking? Shadow maps? I don't really know the names of everything very well. But what I'm going to do right now is I'm just going to render the scene from the perspective of our directional light, and then render that to a texture, and then resample that texture when rendering our actual scene. Okay. So when we render, we're going to say that somewhere we set the camera position. So we do that on every update loop of our app. We say, hey, here's our camera position, and set the camera transform. And I guess we also have like this light position. And I guess all we really have to do is set the camera position to be the light position. Seems reasonable. We also have to make sure that the camera is like really fucking far away, so that we get the whole scene in, so we don't like lose anything behind the camera. And we also probably have to make sure that like the width and height of everything in our projection like gets everything in the scene in it that we care about. So for now, let's just try. Let's see, we have like a light direction, and so we need to like create a transform from that direction. When you do your shadow rendering, is it ortho or perspective? I assume orthographic is the right answer here, because we have like a uniform directional light. It's not like a point light where you have like if I had like a light bulb over here, he's kind of like radiating out light in all directions. And so in that case, it would be perspective, I think, would make sense, because you'd basically say like, hey, there's like some rays coming out at this angle, which looks a lot like a perspective render. But since we're doing a directional light, then an orthographic projection, I think, is the right answer. Which means that we're going to have to, like, in our shader, disable perspective. So I guess let's do that first. That's the easiest thing to do, is just to say uniform disable perspective. Uniform, I wonder if they have bools in OpenGL, I'm not sure. And I guess we'll say enable perspective, because double negatives are a pain in the ass. Let's see if that compiles, and it does compile, so bools do exist. Very nice. And so now we can just go through some of the love of hooking this guy up. So in our mesh renderer, we can say one of our uniforms is going to be enable perspective. Enable perspective. And this is going to be enable perspective location. Then we're going to have to write that guy down over somewhere. So we'll say enable perspective location. And over here somewhere, we're going to say enable perspective location. And then just one of the many things that we are capable of doing here is setting perspective. Or set perspective enable. And this is just going to be enable, takes in a bool. He's going to write that bool to uniform 1. I guess it will be a U32, even though we wrote bool in GLSL. It doesn't seem like we have the option to write one there. So we'll try saying enable perspective location. right enable as U32. Am I allowed to do that? Okay, cool. And then let's just try disabling perspective and see what that looks like. So we'll just say mesh renderer set perspective enable false. Shouldn't that depend entirely on the projection matrix set to the shader? If we were using a proper perspective matrix, but we've just got it hard coded in the shader right now, our perspective is just like, we just do it. Which is maybe wrong, right? But I wanted to initially I could reason about like the XY scaling a lot better, and now we've kind of done some learning about the Z scaling as well today. But I couldn't, like, if you had asked me to generate a perspective matrix by hand initially, I wouldn't have been able to. And also I was like, I don't really see why I need it. Now it seems like, yeah, maybe it would be a little easier to it would be a little easier. How do I say this? Maybe it would be easier to construct a perspective matrix on the CPU, but maybe not. I'm kind of okay with this way of doing it for now. Because I don't need support for any arbitrary matrix. I really have like one thing that I want to do. So I'm okay with doing it this way for now. Okay, so that's perspective off. Depends on if you see yourself adjusting the field of view or whatever. Yeah, but like I don't really see why it's any worse to like be like uniform float FOV in here versus generating the perspective matrix on the CPU. Like I feel like the reason for the perspective matrix is like the matrix allows you to do a lot, right? You could like skew the top and bottom. You could do like wacky shit. You could render everything on an angle. But I don't really want any of that. I have like two states, orthographic and like normal perspective. And so I could be missing why that's better. But yeah, I don't know. I'm of the opinion that I do what seems reasonable until I find out that it's not. What seems reasonable to me specifically with my like low amount of knowledge and low amount of experience. And that hopefully will run me into more problems, and then I'll have a better intuition about why people do things the right way. Of course, if I were doing this in the real world, not just for shits and giggles by myself, I would do the industry standard thing for sure. But if the goal is to learn, then going off the trodden path and fucking up often results in like a better understanding, at least in my experience. So if I set this true, we see this guy. And if we set this to false, we see this guy. We probably still need to do some like near plane, far plane clipping. But since in we just went through all of that like work to figure out that like 1/z is linear in screen space. But when we're in orthographic mode, I think that we don't have to do any of that crazy shit. So we can just say outvert.z divide equal by 10 or something so that we get stuff that's far away. There we go. Looking nice, looking nice. I'm pretty sure that's a correct orthographic thing. It feels like the aspect ratio is not being taken into account correctly because that's in the wrong section of the aspect ratio handling ended up in there. But I think is that orthographic? It's actually kind of hard to tell. So we'll turn it on and off, and maybe we'll toggle it on and off over time. So we'll say perspective enable is equal to time over like mod 2.0. So it'll go from 0 to 2, and we'll say if that's, I guess we do mod 1.0 and say if it's greater than 0.5. And we should see it flip-flop every 0.5 seconds, and I feel like I'm not seeing that. Let's say let perspective enable is equal to this, and let's just double check that I'm setting that correctly. Just double check. So this is equal to this. And perspective enable, and we can print line perspective is perspective enable. Perspective, because I spelled it wrong. Sure. So he's just always false, which makes sense. So I'm clearly not using time correctly. Oh, why am I subtracting time here? I should be adding time. Okay. That makes it, that gives me some like heavy confidence that the orthographic view sure is not the perspective view, because the perspective view looks way fucking different. Cool. Looks like that's working. So, we'll say at some point we disabled, or enabled ortho, added option for orthographic projection. And now we essentially need to figure out the rotation that we need for the light. So we're setting the light direction by essentially picking a vector. So we're saying like light just comes in at this arbitrary direction in 3D space. And I don't know how to convert a random, an arbitrary 3D vector into a transform. So I wonder if there's like, I guess, is this just, if I have like X, this is going to be, well, let's do it in 2 dimensions first, and maybe we'll like figure out the answer. So say I have a vector that's pointing here. Womp, 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 womp. I guess this is going to be defined as some X and some Y. And this is a right angle triangle. And we could then, like, finding out the angles that it's rotated around each axis is pretty straightforward. In fact, we only have one rotation around the z-axis, which is this guy. And that's pretty easy because you just can do like an A10 there to get that. But then what happens when you start doing it in 3D? So like I could like easily find if this is like X, Y, Z. I could find this angle pretty easily. I could find this angle pretty easily, but I don't know if I could like combine them sanely. Because like I would need to rotate it backwards to get the Y position. Cross, ran, and up. Oh, that seems pretty reasonable. Right, so I can say I have like an angle and I have my like up direction, and then I get like the normal vector out of it, or the vector that's like orthogonal to both of those, and that does that give me the right rotation? Not really sure. Vector to rotation matrix. Let's Google it, because I feel like I don't feel like I'm getting it. This is axis angle, which also I feel like isn't what I want. Normal vector to rotation matrix, is that what I want? This is kind of what I want. Start by translating a plane. Is this like a look at function? Probably, yeah. Look at GLM. What does this guy do? So GLM look at. Look at. What does it say look at does? Requires a position. Is this like, does there docs? Why does clicking this do nothing? Oh, that's interesting. Creates a view matrix that transforms coordinates in a way that the user looks at a target vector direction from a position vector. Ah, okay. So that is kind of what I want. The lookout function expects a position, target, and up of the global world to form the resulting transformation matrix. Also makes sense, right? We do need an extra up direction. that makes sense. The parameters are the position target, blah, blah, blah. And like, what's like its definition? So oh, this is his code. I don't want his code. The real answer looks like this. Jesus. So this is probably YX. It might be XY. XXX is on these guys. So S, U, and F, where S is the cross product of F and up. So that's reasonable, right? So I think. Where cross product essentially gives you like the orthogonal thing. So F is a vector. Oh, sorry. S is this guy. So here I have normally one would just define a Euler rotation for a directional light, then convert that either to a matrix or vector as needed. That does seem easier instead of, because then you could just take like a vector of like 1, 0, 0 and apply the rotations. That would probably be easier than this. But I'm already here, so I kind of want to see if I can understand this a little bit. So here they have an up vector. So let's say that we say like up is y up. Does that even work? Does my y have to be... that's useful. And then I can pick like any other vector, like the light's coming this way, and then I get the cross product, which is this. So this is S, this is up, and this is F, I guess. And then they're saying like your X, if you have like 1, 0, 0 on X, you're getting forward as Z, which makes sense. You're getting up as Y, also makes sense. And S is your new X. That doesn't seem that crazy. And then they're multiplying, or they're adding in the projection of that onto the eyeball. I feel like intuitively, like I'm looking at those operations and I'm not seeing anything that's like, wow, that's wild. Like it kind of makes sense, but I don't think I fully understand it. But that's okay. We can just steal this guy and look at matrix, just making orthogonal basis and then setting the rows and columns of the matrix this way. Yeah, it does seem like that's what it's doing when I look at this implementation, if I understand it correctly. Yeah, okay. We can try that. Looks like their column matrix is kind of, how do I say this? It's row major instead of, or column major instead of row major instead of like what we're doing. So we're gonna have to invert those, but it's very possible that I just copy paste this and it makes sense, like it works. So we'll say pub function look at, and what are its inputs? It has a I, which is, what is I again in this? The direction that we're looking? No, it's where we are. The center is where we're looking. And up is just going to be Y for us. Okay. Sure, that's usable. So this is a bunch of floats. Center is also some floats. And up is also some floats. F32, 3. And this will return a transform. Okay. Then we paste this. And we say let what the fuck? Oh, this is not what we wanted. There we go. We're missing the end bracket, so that's this guy. And then we say let transform is equal transform I transform I new transform identity. We'll start from identity. Here we need to normalize our vectors, so we just have to create that function, I guess. So function normalize is, do I have that already? No. I guess there should be a public function normalize for a vector, which is a bunch of floats, to a new bunch of floats. And he's just going to take the sum of each of these guys and divide them by, or he's going to sum the square and then square root them, right? So he's going to say let L squared is equal to the vector into as an iterator mapped to the value to the value squared, and then summed up, and then we return f32 squared. I guess the length is the square root of all of these guys. This, and then we just return. We return each of the elements divided by the length, like this. Okay, and then I guess we should test one of these just to make sure. So we're gonna normalize like 1, 2, 3, and if we do the math there, I guess we could do the math by hand, or we could get Python's NumPy implementation to do it for us. We could. So let's do Python 3, import NumPy, let b is equal to 1, 2, 3, and then, oops, there's no let in this language. NumPy dot, is there like not a NumPy normalize? There must be. Lionel G norm. Who's Lionel G? Who knows? So this is the answer that he got. And so we'll just say assert this is equal to this. I guess we can't do an assert equals because it's float, so we'll do an assert that this is close to that. So we subtract it and we do an absolute value. Linear algebra? Wow, I just always thought it was some guy's name, Lionel. That's absolutely fucking stupid, but now that you say it, it makes a lot of sense. So we'll say that this is like a small number, and cargo test. Oops. I've got effect 3 sitting around here somewhere, so we'll just comment out this whole function, I guess, because it's not finished. And hopefully we get a passing test. Oops. So our normalize function is supposed to return a vector. Oh, so I guess I need to do numpy array v over this guy. Is that right? Does this look right? That looks kind of right, maybe. Expected is equal to this. And for for expected calculated in expected iter zip normalize 1, 2, 3. We do this assertion, but we only do it for we absolute value the expected minus calculated. Alrighty. There we go. Test normalized passes. Cool. And if we chuck in a different number here, just to double check, that does not pass. So looks like we did the math correctly. Look at us go. Look at us go. All right. So now we can say let f let u, let s. U has to be modified, so there's no cross product here, so you have to implement that too. And I don't remember the math here. I haven't looked this up for a while. Cross product is defined by this guy. AXB is the length of A times the length of B times the angle, sine angle between them. How do I calculate that from the vectors themselves? Ooh, here we go. Using column vectors, we can represent the same result as follows. Oh, I see. Is this just like, is the cross product just like a fancy word for... Oh, here we go. It's this guy. I see. Cheap to calculate and gives us some interesting geometric usage. Cool, cool, cool. So I guess I just copy this. Yeah, I guess I just copy this. So this is Jesus. So we'll do the same thing. We comment this out. We implement a quick cross function. Pub function cross A and B is these guys, and he returns a new vector. And this is just A2, or is this 1, 2, 3? These are one index. So A1 times B2 minus A2 times B1. And we just have to update the indices here. So this is, these are each added by 1. Like this. And these guys are also added by 1. So this is 0, 1, 1, 2. Okay, and then we just do a quick test cross product. And we just do let v is equal to 1, 2, 3, and v2 is equal to 3 or 4, 5, 6. And numpy.cross v2 gives us this guy. So we can just do the same thing here. Womp, 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 womp. Expected is this, and we are crossing 1, 2, 3 with 4, 5, 6. For our test. Oops, we forgot to put a little comma here. We didn't like that, so possible that I fucked it up. Cross 1, 2, 3 with 4, 5, 6. Let me just double check that numpy.cross is indeed the cross product that I expect it to be. Cross product of A and B. So is it possible that I just fucked up again? A2, which is 1 when 0 indexed, B3, minus A3, B2. Oh. The second one is supposed to be negative? A1, B3. Oh, yeah, no, so this is A3, B1 minus A... Oh, is this offset on these guys? Let's try that again. There we go. Fucked up the indexes. But it does look like our cross product is now giving us the expected answer, which means that we can use it over here and start implementing this lookat function again. So we have the transform, we have F, we have U, you have S. And we'll just write unimplemented before all this, and hopefully all this should compile. Oh, we can't do subtractions here. I guess it might make sense at this point to create a vector type. So struct vec3 is just a wrapper around F32s, but we need to implement something for it. So we'll make a function new that takes in an f32.3 and returns vec3, which is just vec3 elem. Boom, boom, bing, bang, boom. This is public. This is public. And now we can implement std ops sub. Why not from? Probably should implement that too, to be honest. I just didn't think of it when I started typing. Impl sub for vec3. And we will say right hand side is equal to self. And so we just do element wise addition. So we say let ret is equal to 32.3. I guess 0.0323 like this. And we say he's mutable, and we say ret for I in 0 to 3, ret I is equal to self I plus right hand side I, and then we return ret. Easy. And the output is another vec3. Cool, 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 cool. And as you said, I should be able to write ret into here, which means I can do impl, what is it, std convert from for vec3. And do I need to say this is from a f32.3 like this, probably? Nice. And here we just say self value. Easy. Easy, 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 easy. This also needs a .0 on him because he's indexing the thing inside. Bing, bang, boom. Cool, 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 cool. Which means that now everywhere we're using these like f32.3s, these can be vec3 like this. Which means that this normalize should take in a vec3 and return a vec3. This cross guy should take in vec3s like this and return a vec3. And all of these guys just get .0s in front of them. Boom, boom. And then we throw a little .into on the end. And this guy also gets these .0s on the end and a .into. Bing, bang, boom. Bang, bang, boom. So now we probably have to update our tests too. Probably we just throw a little .into here. And then we need to like get the inner thing out again. And I think that will compile probably. Cargo test. We're close. Vec3 does not implement copy, so we'll just derive, debug, copy, clone, whatever. Doesn't fucking matter. Nice. Okay, so we got our compilation working for normalize, and we have to do the same thing for this guy. So he's gonna want a .into for each parameter to convert him from like a 3-element array into our new vec3 type, and then we're gonna have to take the thing out of the calculation we did. Nice. Okay, everything compiles. We're back and working. So now we have this like little subtraction thing. Very nice, very nice. We have U, we have S, we have F, and we just say we've already got our result. These are called transform. And I'm pretty sure that the row order is broken here. So I think what we can do though, if we get fancy, is we can write a macro that changes this word to transform. And I think inside we call him Matt. Then we just swap the order of these guys and come back here. Boom. And we can double check that that makes sense by saying that our first column should be only applied to X, which it does look like that's true, because we have row column. Nice. Nice, 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 nice. And we'll say that we copied from somewhere here and rearranged. Turns out it's not transform.mat, it's transform.array, which is just a bad word for this, but it is what it is. And I guess we have x, y, and z here. So it kind of makes sense now for our vec3 to have getters for x, y, and z. That makes sense to me. So we'll say x takes in self by reference and returns an f32. And he just returns self 0. And we can do the same thing for y and z, but we return 1 and 2. And that means that this function that we just stole, we can just kind of go like, whoop. And that will fix a bunch of compilation errors. And now we just need to have a dot product as well. And a dot product is easy peasy. It's just the sum of each of their things, I think. So if I go like 0, 1, 2, 0, 1, 2. Is that right? Dot product. I have to look it up because I don't have it memorized. Yeah, so it's just, oh, right, we don't return a vec3, we return a float. And it's just the sum of each of their elements multiplied together, so. Like this. And we can just do another quick one where we say numpy dot bv2, check the answer, he gets 32. So we can just copy paste that and see what happens. So here we can say test dot. We don't have to do this like loop thing anymore. We only have one value to check. So we say dot 1, 2, 3, and 4, 5, 6. What we say let return is the dot product of these guys, and we can assert that the absolute value of ret minus 32.0 is less than some small epsilon. Easy peasy. We test it. We fuck it up because somebody's still returning result. This guy should be returning transform. We tried to extract an inner value from a float, which doesn't exist. And so that looks like it's working. And now we might have a lookout function that just works. Who knows? They might have like a negative convention that we don't have for z, so we have to be careful about that. But otherwise, we'll see. All right, I have to go to the washroom. I'll be back in like 1 minute. Be right back. And we're back. We are back. Oh man, is that PY03? Okay, so we're not actually doing any Rust Python interop right now. I'm considering it eventually for a future project, but right now we're not doing any of that. We're just using Python as like a reference for some like linear algebra functions because I'm too stupid to do the math by hand and be confident that it works. So I'm like running it in Python and double checking that my answers are similar. Okay, so we have this lookat function, and that should be able to take like some direction and turn it into a transformation matrix that we can use to set the camera position, or this camera, sorry, position and rotation and scale. You know how it is. I've been probably fighting PY03 for the past week. It's so frustrating. I've worked with it before. It doesn't seem too bad. It seemed like okay. Let me see if I've like, I think I have a project probably on GitHub that uses this. One of the many. Oh no, I'm remembering a work project that I don't have on the internet. So, anyways, you'll get there. Quick question: have you worked with Golang and do you like it? Never worked with Go. I feel like it's not a language built for me. It seems like it's a nice language, but it's not really how to say this. Like it's garbage collected, and very like simple, which I think is like those are both like very nice. But it seems like it's built for like large scale web services, I guess, right? Like it's got like a big thing around like green threads and like for like efficiency with networking, and like, you know, you're optimizing for like the programmer there in some way too, because you don't have to worry about like memory management. I've never worked with it. I just haven't. I'm sure I like at some point I might come across a project where it's a good fit, but I haven't really written much web servers in general, right? I haven't written many services in general. I'm generally working with like one thing service like that's running on my machine, or like on like a, you know, I worked with like security cameras firmware in the past, and so it's just never really come up. So I haven't tried it, but it seems cool. I've heard that there was a little bit of like a hubbub at some point about their like metadata collection in their compiler, but that's about like, I mean, I think that's just like programmer drama and nobody actually really cares. Anyways, okay, so I have this lookat function. I don't know if it's right. We haven't tested it at all, but we should be able to say we set our camera to, maybe we set it like the same way that we moved it back on Z. We'll still do that. So we'll set our eyeball for now at like negative 1.0 or negative 1.0, 0.0, 0.0. And we'll convert this into a thing. We'll say transform look at. Then we will say that the center, we are looking at 0.0, 0.0, 0.0, the center of the world. And up, we want to be in Y, so we're going to say 0.0, 1.0, 0.0. And we are going to see if that results in us looking horizontally at the center of the world of our scene. And if it doesn't, then we fucked up in some way. What the fuck? That seems like kind of right in the orthographic projection. Really fucking wrong in the in the perspective projection. And also it's like not centered, which is pretty odd. What happens if we set our like up direction to down? Do we get 90? Okay, so that seems pretty reasonable. Why are we looking at the back now when we were looking at the front from before? Something here is not right at all. Not right at all. So I think that the convention for how do I say this? The convention for GLM is that like the camera is facing backwards and we have our camera facing forwards. So we might have to do something like invert Z. So we'll just say transform let invert Z matrix is a transform with identity. and then we just set our z value in this to -1 instead of 1, I think. And then we can return the transform with an inverted z. And that still looks absolutely fucked. Let's move the camera. Let's maybe look at what this is doing. Like, what do we get out of this? Because we can probably, if we are saying look at 0, 0, 0 from this position with y up, we should be able to just look at that transform and see if it's fucking reasonable and how it's wrong. So let's just print line, camera position. Are you using burn by any chance? What's burn? Burn. Oh, that's not good. Oh no, it's just people with burnt hands. Fuck. Burn programming. Laser engraving cutting. Burning images to microcontrollers. Well, maybe if you burn Rust. What is this? Wow, look at that. He's got like a little flame in me. Do you think he was fast? Goal of a deep learning framework is to convert computation to useful intelligence. We made performance a core pillar of Burn. But what is it? Is a new deep learning framework. Oh, that's interesting. I have an AI project in mind that I was going to jump on after this. And so maybe it would be cool to look at it through here, but maybe not. I like what so I guess I am not using Burn because I haven't done AI for a little bit. I did work with it at my last job. But no Rust at work ever. So that's a no for me. Okay, so let's write down the camera pause here. And maybe we can print it. And what we should be seeing is we should be seeing a translation along Z. Why the so we've seen no Z translation, which is odd. We're seeing like a complete identity matrix, right? Am I crazy? Oh, no, we're not. This is not identity. We're seeing a rotation with a movement along Z. That looks right. Okay, so this is, it would be nice to like make a better print of this guy. So let's go back to our mat thing, and we're gonna manually write our debug implementation so that it's like a little bit nicer to look at. So we're gonna say impl, what is it? Stood format debug for transform. And he's gonna be like, hey, there's some missing things. And I'll be like, hey, could you write them down for me? Because I don't know what they are. And we're gonna write to this formatter. So we're just gonna say, essentially, write to formatter. And what are we gonna write? We're gonna write each of the elements kind of just like out as they should be, you know? So maybe we'll start with an open brace. Is your vector sub implementation correct? It looks like you're adding there instead of subtracting. Jesus. Dude, do you know how many like just absolutely fucking brain dead mistakes you've caught for me? It's so many. And it's just like, yeah, obviously that's fucking wrong. And I like the way you phrase this where you're like, I can't remember vector math, but I'm pretty fucking sure that an addition isn't a subtraction. It's like, yeah, fucking of course not. Thank you. I'm still gonna finish writing out this debug right. Jesus Christ. Okay, so we're gonna write 1, 2, 3, 4 things followed by a /n, and we're just gonna do that 4 times and kind of finish that off with a square bracket. And I wonder if there's like a nicer way of doing this than doing like self.array 0, 0, and then just like fucking like copy pasting this a bunch of times. But probably not. So this is 1, 2, 3. This is row by row, so I think that's correct. And then we just copy paste this a few times. And we replace these guys with 1s, and these guys with 2s, and these guys with 3s. I will say, Vim is nice a lot of the time, but holy shit does it enable, like, what some people may consider poor behavior, right? Like the fact that I'm like, oh, I'll just write them all out. That should like cause some pain for me so that I don't do it. But instead, I'm just like, speech swap works for me. Okay, what? My indents? Or there's something wrong here where my brackets aren't matching in some way. Cargo check. Oh no, that's working. Cargo run. Okay. So my camera position, I'm seeing a -1 in Z plus some rotation. And is that what I expect to see? Position, I think, is right. Where am I? Where am I? So my... What are these parameters again? My eyeball is at -1 along X, which is actually not what I wanted to do. I wanted to put my eyeball at -1 along Z. So let's do that. My position now, I am seeing like a -1 around Z, but also with like a rotation, which seems about right. It's odd that my orthographic projection is ending up upside down relative to my non-orthographic projection. I don't understand why that would be. I guess if like the stuff is somehow ending up going through the camera in the perspective projection or something. Right, like if my camera is like here, like you can kind of like imagine like a pinhole camera model. And sometimes, like, if things end up behind the camera, these lines get, like, extended. So things that were on the left over here end up on the right over here. And my camera, like, thinks it's always facing forward, but it renders stuff behind it. That's, like, a possibility for why things are flipping. I'm also a little confused about... I feel like I'm rotating around... I feel like I'm not looking at Z-1. Can we, like... import the object. Okay, let's compare this to the manually constructed transform, which is just a translation along Z with no rotation. Because I think that's what we think we should be making with that guy. So we should be saying, please move backwards 1.0. Yeah, see, this is what I expect to be seeing. Could be a left-hand versus right-hand issue. Yeah, that seems like very likely to me. I think that like, I'm almost positive that's true. Okay, so we should be seeing it from the side. And our perspective should not be changing. And we can also keep printing this camera matrix. And it seems like, this is what we expect to see. Identity matrix with just like a translation along Z. That's what we expect to see if we are doing this look at. We're saying look at a translation along Z with Y up. And let's just try doing our translation in the other direction. Oopsies. I didn't comment out the other thing, so of course it's going to continue working the way we expect. Close. Maybe if we invert Y as well here, then we get the expected results. No. I think it is. There is some like left-hand, right-handedness that we have to account for in here. Hear me out. Hear me out. I'll just delete those negatives and see if that looks a little bit more expected. So here we want a -1, and here we want +1. Which is just giving me what I wanted, which is pretty fucking funny. Okay, so let's now say that we are at 1.0 along Y instead of along Z. Now that didn't work, because obviously what we just randomly deleting negatives is not the right answer. Ever. Okay. Fuck. So cross products are gonna move in a certain direction. I guess we need to... Is this the same thing as just like a 180-degree rotation around Y? Oh, this shouldn't be negative. You can't look down. Why can't I look down? Because the math is wrong? I'm going to be honest, don't understand the math in the slightest. But I imagine that I should probably be rotating. I think that in GLM's world, the cameras are the usual convention for OpenGL is that the cameras are rendered with negative Z, but I'm rendering positive Z. So maybe I do like a rotation around the Y axis. Up, cross, center, minus I is wrong. Because your up vector is hard-coded, if you try to look along the up and down vector, your cross product will be busted. Oh, that's a good point. I meant to say X when I did this. Yeah. Sorry, yeah, good point. So, I did want to try well, let's go back to the other thing because I don't want to just like randomly delete negatives. That seems fucked up. And let's see if I do think that maybe just like a full rotation around the y-axis might work here. So we can say transform from axis angle, where my axes are hard-coded, my angle is in radians, and I'm trying to rotate by F32 stood, F32 pi, consts pi, nice, and around axis y. And I can multiply that by the transform I got. Axis is not the same as axis. And if it's just that they're pointing negative and they're supposed to be pointing positive, and the rest of the math works out, I should see a matrix that I expect. Which seems close, except X is maybe flipped, and my Z... Hold on. What did I write here again? I want it to be at negative 1.0. Looking forward. Okay, yeah, that's fine. So, except for my perspective matrix is broken again because of these really tiny numbers. Is that really all it is? Because my numerical imprecision is making my perspective look totally fucked. Hey, do you have a streaming schedule? Love the content, but I gotta sleep. Yeah, I sleep. I sleep. I can tell you what time I sleep too, but that's not really that helpful. I stream most days between 1 and 2 o'clock Pacific time for around 1 or 2 hours, depending on what I'm working on. Yeah, some days I take off. I probably stream around like 7 out of 9 days ish. But yeah, no real like weekly schedule, but there is like a daily schedule with some breaks in there. And if you miss anything, there's a YouTube channel linked in the Twitch description if you want to like catch up on VODs. Okay. So now I'm kind of weirded out by the fact like this matrix looks right to me. It's looking no rotation, looking forward. Oh, and it's moved forward along Z instead of backwards along Z. So that's my problem. So I guess I invert Z as well, and then the rest I think probably works out. Is that right? Invert Z. Thinking. That doesn't sound right. It's more that like, why is my transformation here wrong? Do I have to actually like understand the math? Oh, I didn't want to have to do that. I didn't want to have to think, but here we are. So first you normalize the vectors you use. Yep. Then you just make sure the up vector is perpendicular to the direction, and right vectors as you recalculate it as a cross product. Because when you give you another up vector, you make blah, blah, blah. The matrix is constructed from these. For more detail on how it works, check this guy. In short, this is a matrix which creates a new coordinate system so that the columns are the axes. The last column is the translation. Yep, understand that, but okay. So I guess these F, U, and S probably stand for forward, up, and sideways. So I want my X to look sideways, my up to look up, and my forward to look forward. And so the only thing I'm missing here is why are these like negatively moved along the X, the sideways and up directions? I guess because if I'm looking up, I need to move down. And if I'm looking down, I need to move up. So really it should just be if I'm inverted in some way, it should only be my z's that have to change. And it should probably just be the direction that I'm moving in z. Like the forward is backwards. If my thing is the other way. So I think this probably makes sense, and maybe this. Maybe. So we get a 1, 1, negative 1, 1, and so I guess maybe it's just on translation. So now I'm seeing no rotation and a movement on backwards on z by negative 1, which makes sense to me. That lines up, right? And if I move positive 1, I should see us looking, we should see like a 180-degree rotation around the y-axis and us looking forward if we're looking at the center. So here we see a negative 1 on x and z, which I think is a 180-degree rotation around the y-axis. The z movement is still negative, which is a problem, which means that some of the negatives I flipped here are just incorrect. Can I undo this a little bit? Oh, should I not be doing this like rotation again? So sideways, this seems reasonable. This seems reasonable. This also seems reasonable. The only thing that we might have backwards compared to what these guys wrote is that our z might be, we might be saying that we want to look through positive z, not negative z. So it seems like maybe we just invert what forward is. That seems reasonable. That seems like it might do what I want. I feel like this isn't how I'm supposed to do math, by just like kind of like fucking guessing and checking. But sometimes this is the way it ends up because I'm an idiot. Vec 3. Sometimes it's just the way it goes. Oh. That looks good. If I am forward by 1 looking at 0, and if I go backwards by 1 looking at 0, that does not look good. Fuck! God damn it. Okay, I'm gonna have to like actually write out some math, and I think that instead of just guessing and checking on stream, I will think about it and come back tomorrow. So I was hoping that we would get farther on this shadow thing, but I'm getting stuck in some of the linear algebra because my math is a little shaky. But that's okay, because that's why we do this, is to learn and get comfortable with this kind of thing. So I'm gonna hit the books and come back tomorrow, hopefully a little bit rejuvenated, and try to continue on with this like shadow mapping stuff. If you liked what you saw, I stream most days around 1 or 2 o'clock Pacific time, and I stream for around 1 or 2 hours. If you miss stream and you want to catch up, there's a VOD channel that's linked in the Twitch description. It's on YouTube. And if you're watching on YouTube and you want to come by, say hi, chat, help me with my linear algebra, there's a Twitch link in the YouTube description. Yeah, other than that, there's a GitHub also linked in my Twitch description where like source code gets up for things that get finished. So this project in like the state that you saw at the start of the stream is on there somewhere. And there's a Discord for some people who are asking for like a way to chat when I'm offline. So there's a Discord there if you want to join it. I post like announcements and VODs in there, and then there's like a general channel where people chat about shit. Otherwise, yeah, thanks for watching. I'll catch you guys in the next one. Bye!